Advanced Math, Lesson 41, Reciprocal Trigonometric Functions and Permutation Notation. By the reciprocal trigonometric functions, they're just talking about reciprocals of our main cosine, sine, and tangent functions. I'm going to draw that over here. So we'll start with the example of cosine. So if we have cosine of theta, one way to think of that if we use our normal trig functions is that's the adjacent over the hypotenuse, right? And the reciprocal function would be just to take this and put it underneath 1 or to invert it, right? So the reciprocal would be like saying 1 over cosine of theta, right? Which would be rewritten as 1 over the adjacent over the hypotenuse if we write it as a reciprocal, or if we substitute that for cosine. And then to simplify that, the reciprocal would just end up being the hypotenuse over the adjacent. So we take the cosine function, we flip it upside down, that's the reciprocal. Now all of these reciprocal functions have specific names. The reciprocal of cosine is called secant, abbreviated SEC. So hypotenuse over adjacent is equal to the secant of theta. So cosine, secant, opposites. Now when it comes to sine, we get the opposite over the hypotenuse, right? And the inverse, or the reciprocal, is going to be called cosecant, which is hypotenuse over opposite. And the way I always remembered cosine and sine is that if you look at the first letters, they're backwards. The reciprocal of cosine becomes the S word, or secant. The reciprocal of sine becomes the C word, or cosecant, right? So that's how I always remembered. Reciprocal is kind of like flipping it upside down, so let's go ahead and flip the letters as well. Cosine becomes secant, sine becomes cosecant. The last one, tangent, I never had any issues memorizing because it's pretty simple. So the tangent of theta, we remember, is the opposite over the adjacent, and the reciprocal function is just called cotangent, or COT. And that becomes the adjacent over the opposite. So those are our three reciprocal functions. Ignoring that. So this one, and this one. And we got to learn how to use these in problems. So I'll do a quick example. The first example they give us is to evaluate the secant of 330 degrees added to the cotangent of 480 degrees. So how do we solve this? Well, first we'll go ahead and figure out where these are on the coordinate system. So if we take 330, that takes us through the first, second, third, stops in the fourth quadrant. 330 degrees gives us an excess of 30 degrees. So we'll be finding the secant of 30 degrees. When it comes to cotangent, we go all the way around to 360. 360 plus 90 gives me 450. Plus another 30 gives me 480. So that gives us the extra of 60 degrees. So we got to find the cotangent of 60 degrees. I'll go ahead and draw our 30, 60, 90 reference triangle. We got 60, 30, 90 opposite the 60. Oh, I drew that backwards. This one's not nearly as good, but there's 30, there's 60, that's 90. Opposite of 60, we have square root of 3. Opposite of 30, we have 1. Hypotenuse of 2. So, to find the secant of 30, I'm going to take the cosine of 30 and then flip it upside down, right? So the cosine of 30 is adjacent over hypotenuse, adjacent being root 3 over 2. So I take root 3 over 2, that equals the cosine, and then I'll take the reciprocal, 2 over root 3, and that gives me the secant of 30 degrees. Now, let's go to the cotangent of 480, or the tangent of 60. So if I did the tangent of 60, that would be opposite over adjacent. So the tangent would be root 3 over 1. And then the cotangent, or the reciprocal, is going to be 1 over root 3. So all I'm doing is I'm adding 2 over root 3 plus 1 over root 3. That gives me 3 over root 3. The problem is, though, this is an irrational denominator, so I'll go ahead and rationalize the denominator, which gives me an answer of 3 root 3 over 3, one last thing I forgot. Hold on. I forgot to evaluate the sign. So if we look at cosine in the fourth quadrant, cosine is positive, right? All students take calculus, so the inverse is positive. So this one, 2 over root 3 will remain positive. However, I forgot to look at tangent. All students, tangent is negative in the second quadrant. So this should be a subtraction sign, which means instead of 2 plus 1, I should have 2 minus 1, which gives me 1 instead of 3. It gives me 1 root 3 over 3. So that's our final answer, 1 root 3 over 3. And that's how we evaluate reciprocal functions. We just have to learn 3 new words. Next one, permutation notation. So we've already done permutations where we say, you know, if I gotta put, if I've got 12 different chocolates and I gotta put them in a box that holds 6 pieces of chocolate, how many different possible ways are there to pack this box of chocolates? We'd take the 6 options we have to pack chocolates, and then we'd start from 12 and we'd go to 11, 10, 9, 8, and 7. We'd multiply all those numbers, and then that would give us our answer, right? So that's a permutation problem. We've been doing these problems in word problems, but we haven't really showed you guys permutation notation. Kind of like summation notation, where we use the value sigma to show that we're adding an infinite or limited number of sums. So that, yeah, for summation notation, we use this Greek symbol sigma, right? However, for permutation notation, which is the mathematical notation for these problems, we keep it really simple. We just use the number p. Now, what we put around the number p is the first number, which we call n, which is the number of objects that we have. In this case, we have 12 objects. All right. The number p, well, the letter p will always be p. It's just like sigma. It shows us what we're doing. It will never change. It will always be p. And then the last number they put down as r, which is kind of like the rate or the number of rotations, I guess. I'm really not sure why they choose the letter R. It might be rate, but R is simply the number of slots that you have open, or the number of open spaces that you have. So to do a permutation notation of this problem, where we have 12 chocolates we want to fit in a box that holds 6, it would be written as 12 permutation of 6. So that's the notation for this problem. Then we would just solve it as 12 times 11 times 10 times 9 times 8 times 7. Which, for those of you who are wondering, calculator. Equals 665,280. So that would be the answer to that problem. So this is the notation that we're going to be using. Now, when it comes to solving them, there's a faster way that we can solve these problems, and they're going to show you this in this formula. So one of the fast ways that we can solve this problem is, and what this notation helps us do. This formula is actually derived from using this notation, but the formula is n factorial over n minus r factorial. So if we look at this problem, 12p6, the fast way to do this would be to take 12 factorial, put it over 12 minus 6, and then take that to a factorial, which 12 minus 6 is going to equal 12 factorial over 6 factorial. Once we see the problem this way, it's a little bit easier to solve, because then we can just punch it into our calculator that way. Because what we let's see here, what we can do on our calculator is, wait, hold on, pause. Okay, so instead of having to the value in this is, instead of having to type out a list of numbers like I just did here, where I only do the factorial down to 7. What I can do in my calculator now is I can type in the number 12. I hit this math. Well, my calculator's not on the camera. I might need to zoom out a little bit. I need to get rid of the glare. You know, what if we change the angle? Okay. Maybe I'll hold it. Okay. Yeah, we'll do this. We'll hold it. So we'll take 12. And again, we have to do 12 factorial divided by 6 factorial. So I type in 12. I hit the math button. Find that on your calculator. And then, let me see here. Where is it? There we go. Under probability. So probability. Scroll down to 4 and hit enter. So now I have 12 factorial. And that gives me 12 factorial. But then that's still not very quick. So what I can do to make it very quick, I'll hit a starting parenthesis. I'll type in the number 12. I hit math. Scroll over to probability. Select factorial. Then I'll go ahead and hit the divided button. Put 6. Go back to math. Probability divided by, enter, or closing parenthesis, and then I hit enter, and that is my answer, 665,280, which if we look back down at our work, is the same answer we already got. So again, this equation, so the main thing to learn here is the notation and the equation, and then, you know, another tool that you can use your calculator for. That's it for this lesson. I think this video might have gone a little longer than it should have, but it is what it is. I'll see you guys in class, and if you have any questions, let me know on Moodle.